We'll proceed in parameterization in calculus 2D Jacobian case study. So we are doing case study as far as Jacobian is concerned in parameterization in calculus. So parameterization in calculus, if we see, then we have xy plane and we have fxy. If I have xy plane as independent component, xy plane as independent component, and then I have fxy function over x and y. So if x and y is independent if x and y is a plane that is independent component, x and y plane is independent. So it means that it has two axes, x axis and y axis. They represent independent. What is dependent? Dependent is z. If xy plane is independent, then dependent is z. Z equal to fxy. So in calculus, we discriminate between independent component and dependent component. So if I have xy plane is independent component, then z axis is dependent upon xy plane. So I can take any point on xy plane independently. I can take 2 comma 3, 4 comma 5, whatever. Depending upon 2 comma 3, 4 comma 5, I have z value. How come you can have z value if I have x 4 comma y? How come you can have z value if I have x comma y equal to 2 comma 3, x comma y equal to 4 comma 5? There is a function that relates, z means height, that relates z to x comma b. That function is called f. So z equal to function over x comma y, z equal to fxy, z equal to fxy. If z equal to fxy, then I have for each x comma y, depending upon what function we are operating on x comma y, I get z value. If z equal to a square root of a square minus x square minus y square, then every point in x comma y, it resolves into a z. If I combine all the z, it becomes a spherical surface. Okay. What is the volume of this spherical surface? If there is a spherical surface where fxy or z equal to square root of a square minus y square minus z square, then volume is the sphere. If you take this sphere down, whatever the area it is covering, that area into in 3D, and it get resolves into xy plane. This is the reason it covered in xy plane. This is called xy plane region. This is called region, and this is called fxy. Full this volume, it will calculate the volume. Fxy dxy plane integration over this region is the volume calculated for the surface. Surface is like this. The underneath full volume will come. Not like if I have a ball, this is also a surface only. Surface is spherical. I'm not talking about what is inside the ball, only the spherical surface. If I calculate the integration of this surface along the xy plane, this volume someone would get along with whatever the underneath this ball, whatever the volume that is coming, that will get calculated. Similar way, like if I have x axis and there is a curve like this, if there is a x axis and there is a curve like this, then whatever the area that comes under this curve is the fx dx. Integration of this curve along x axis is this curve area, whatever the area we are seeing, this much, plus whatever the underneath it going to the x axis. So it is like this and this much, this is the x axis. If it is lying on the x axis, the area underneath it. Similarly, if this sphere is centered at the origin, I press it here, it go inside it, centered at the origin, then top hemisphere surface area, top hemisphere volume I would get. But if I keep it like this, then this volume plus underneath the volume, both will come into the picture along the xy plane. So if I have a function fxy dxy plane integration over the region this surface makes on this xy plane, this is circular region. Integration over that circular region means x and y should come from that circular region. So integration over the circular region, like in 2D, the region here, 2D, the region here is this point. Can you see this point? This point is coming here, and this point is coming here. So these two end interval it is called. Over this, I have to calculate the area. That is the interval. In xy plane, it is called region. So if there is a surface, what region it makes on xy plane? That is a circular region. I have to take the integration limit. Whatever x comes, whatever y comes. And then fxy dxy plane. Fxy is also called integrand. Dxy plane is called differential. So that is the constituent. But sometimes we are doing case study, but sometimes it becomes very difficult to calculate the integration. If that is the case, then fxy dxy plane integration over region in Cartesian coordinate system is becomes very difficult. Let's take one case study where fxy equal to x minus y e to the power x square minus y square dxy plane, and the region on xy plane is confined by a line x plus y equal to 3, x plus y equal to 1, x plus y equal to 3, x plus y equal to 1, x plus y equal to 3, x plus y equal to 3 means if this is x-axis and this is y-axis, then x plus y equal to 3 will come like this. Intercept at x-axis at 3, 0. Because here y equal to 0, then x equal to 3. X plus y equal to 1 would come like this. So there is a parallel region. And then other two lines, one is x square minus y square equal to minus 1. And x square plus y square equal to plus 1. So this is like a parabolic. This is like a parabolic. X plus y equal to 1, this line. X plus y equal to 1, this line. Whatever the region comes in between, that region over that region, I have to find the integration of a surface that is x minus y e to the power x square minus y square. Consider this is the surface on top of this xy plane, where the equation of the surface z value is x minus y e to the power x square minus y square. If that is the case, then this surface will land into xy plane in bigger region. I don't want for all the region. I want only the region that come as intersection of x plus y equal to 1, x plus y equal to 3, x square minus y square equal to 1, x square minus y square equal to minus 1. If there are four lines, whatever the region comes in between, over that region if it hits the surface, whatever the reason I am seeing this surface, if you take it down, whatever the volume it is generating, that volume I want. Region over x plus y equal to 1, region over x plus y equal to 3, x square minus y square equal to minus 1, x square minus y square equal to minus 1, x square minus y square equal to 1. Whatever the region it is generating on xy plane, over this region, whatever the surface area it is hitting on fxy, that is x minus y e to the power x square minus y square, that volume, straight that volume over this region, I want to calculate the volume. Understandable, right? So if I have a small region here, that region I take up, that small region I take up, and there is a surface, it hits that region in some area fashion. That surface area fashion, it goes down to hitting x plane. Whatever the volume it is generating, that volume I want. What is the equation of your surface? Equation of the surface is x minus y e to the power x square minus y square. What is the region over which the surface will hit the xy plane? The intersection on xy plane. if I take this x minus y e to the power x square minus y square, it would span over full xy plane. No, I don't want to over full xy plane. Only above a certain region, that is confined by x plus y equal to 1, x plus y equal to 3, x square minus y square equal to minus 1, x square minus y square equal to 1, whatever the region is coming. So net formula is integration over a region x plus y equal to 1, x plus y equal to 3, x square minus y square equal to minus 1, x square minus y square equal to 1, and then integration of x minus y e to the power exponential e to the power x square minus y square dxy plane dx dy. Now if someone needs to calculate it, he would start sweating. I'm really sweating. Okay, it is very difficult to calculate. Let's take help of other coordinate system. What we have till now, I have z fxy. So fxy is dependent upon xy plane. Okay, so the scenario is, if I want to calculate this integrand, then I have fxy, I have fxy function over x and y, that is z. Fxy is dependent upon xy plane. I cannot do it. So I'll use this xy plane dependent upon another plane, that is uv plane. uv plane, xy plane, and then z. Z is dependent upon xy plane and xy plane is dependent upon uv plane. Now xy plane is no more independent. It is dependent upon the uv plane. What is the relationship between z and xy plane? fxy, function over x comma y, that is x minus 1 e to the power x square minus y square. What is the relationship between x and y and uv plane? X equal to, I have to generate one relationship, that is g u comma v, y equal to h u comma v. So if it is uv plane, then uv plane is mapped into xy plane as x equal to g u comma v, y equal to h u comma v, where g and u are functions. Now this xy plane, now it is mapped into z, where z equal to function over x comma y, fx comma y. Three functions are coming into the picture: fxy, guv, huv. Now what uv and x relationship we will take, that is an art. What we are seeing here, we are seeing e to the power x square minus y square. X square minus y square means x minus y into x plus y. And here in the limit, x square minus y square equal to minus 1, again x square minus y square. X square minus y square equal to 1, again x minus y, x square minus y square. X plus y equal to 1, x plus y equal to 3, again x plus y. Looks like x minus 1 and x plus 1 are the key. Let's consider u equal to x minus v, x minus y, and v equal to x plus y. If that is the case, let's draw these four lines into uv plane. If x plus y equal to 1, v equal to 1, u axis, v axis, u axis, v axis. If v equal to 1, if this is x axis and v equal, this is u axis and this is v axis, if v equal to 1, there is a parallel line v equal to 1. V equal to 3, there is a parallel line v equal to 3. So one line v equal to 3, one line v equal to 1. So that is coming because we have two lines x plus y equal to 1 and x plus y equal to 3. What about another two, x square minus y square equal to minus 1, x square minus y square equal to 1? Means x square minus y square is x minus y into x plus y, and another one is x minus y into x plus y. U into v equal to minus 1, u into v equal to 1, means u equal to 1 by minus 1 by v, u equal to 1 by v. So our limit is u equal to minus 1, v equal to the most constant thing we keep outside. So v equal to 1 to 3 and u equal to minus 1 by v to 1 by v. Now the integrand x minus y is u. E to the power x square minus y square is u into v. So u into e to the power u into v dx dy, dxy plane, that is nothing but dxy plane by duv plane into duv plane. So dxy by dub into du dv. This is called Jacobian, dxy by duv. That is nothing but dx by dui plus dy by duj cross product with dx by dvi plus dy by dvj. Okay, someone can do cross product. So it will become dx by du into dy by dv minus dx by dv into dy by du. So dx, what is x? U equal to x plus x minus y. V equal to x plus y. X equal to u plus v by 2. U plus v by 2. Then x equal to u equal to x minus 1. V equal to x plus 1. So v minus u. V minus u equal to 2y. Y equal to v minus u by 2. So dx by du is half. dy dx by du is half. dy by dv is half. So half into half, 1 by 4 minus dx by dv, again half, and dy by du minus half. So 1 by 4 plus 1 by 4, 1 by 2. Surprisingly, I could do it. 1 by 2. So now net is coming, v is 1 to 3, u is minus 1 by v to 1 by v. And now e to the power uv 1 by 2 du dv. Far easy, right? Reason was from x square minus y square equal to minus 1, x square minus y square equal to 1, x plus y equal to 1, x plus y equal to 3, x minus y e to the power x square minus y square dx dy. It resolved into v 1 to 3, u minus 1 by v to 1 by v, u e to the power uv, and du dv into 1 by 2. 1 by 2 I can keep outside, and first we will integrate with u e to the power u first. Okay, so first we will kind of integrate with the u. So u into e to the power uv. So if I do integration, then u into integration of e to the power u by into v, that will become e to the power u into v by 1 by v, e to the power u into v into 1 by v. Because if I do differentiation with u, then it will be like that. So u into e to the power u into v into 1 by, so u by v e to the power u into v minus, means integration by part I am doing. Differentiation of u, that is 1, and e to the power uv is e to the power uv by v. Again one more integration is e to the power uv by v square. So this much came into the picture. So u by v into e to the power uv minus 1 by v square e to the power uv. Now u I have to keep minus 1 by v to 1 by v. So first one would come as 1 by v square. U by v is 1 by, if I keep the upper limit 1 by v, so it is 1 by v square e to the power 1, and then 1 by v square minus 1 by v square e to the power 1. I think this is gone. Now next is minus 1 by v. Minus 1 by v, if I do, then minus 1 by v square. Minus 1 by v square e to the power 1. Minus 1 by v square e to the power 1. E I can keep outside. Okay. And now outside I have e by 2. And then integration of minus 2, then e I can keep outside, then it becomes minus 1 by v square minus 1 by v square. Again 2 gone, only e is outside, minus also I can keep outside, 1 by v square. 1 by v square dv. that will get resolved into v to the power minus 2. V to the power minus 2 is v to the power minus 1 by 1. 1 by v square means v to the power minus 2. So v to the power minus 1 by minus 1. Minus minus out. 1 by v. 1 to 3. 1 by 3 minus 1. So that will resolve in somewhere, I believe, minus 2 by 3 or something like that. So it will, this is what it is. Okay. So someone can, if I have done something mistake in doing the calculation, someone can resolve it. So v is 1 to 3, u is minus 1 by v to 1 by v. U x minus y is u, and then e to the power uv first integrates with du and then integrates with dv. Jacobian is half. Half you can keep outside, and u e to the power uv is, now if someone do integration, then u into e to the power uv into 1 by v. So u by v e to the power uv minus 1 by v square and e to the power uv. Now u is minus 1 by v to 1 by v. If I 1 by v, if I do, then it is 1 by v square and then e to the power 1. E to the power 1 minus 1 by v square e to the power 1. Clean sweep, gone. Another is minus 1 by v. Then it is minus 1 by v square e to the power minus 1. And minus 1 by v square e to the power minus 1. Minus e to the power minus 1 I can keep outside, and then it is minus 2 by v square. Minus, I can keep outside, minus e to the power minus 1. 2 I can keep, to 2 or 2 gone, half, 1 by half gone. Minus e to the power minus 1. 1 by v square. That integration is nothing but v to the power minus 1 by v. 1 by v square integration is minus 1 by v. That is minus minus I had kept outside. I think it becomes plus. So e to the power minus 1 and then 1 by v, limit is 1 to 3. So 1 by 3 minus 1 by 1. So it will become minus 2 by 3. So it becomes minus 2 by 3 into 1 by e to the power minus 1. So 2 by minus 2 by 3 into e. Denominator is 3 into e and numerator is 2. So 2 by 3 into 1 by e. So this way someone has to proceed as far as Jacobian example is concerned. We can take more example in Jacobian. Let's proceed in kind of 3D Jacobian. So simple example we had taken, means very complex example we had taken, but it becomes so simple when we saw parameterization. What about 3D Jacobian? That is under question now. What is 3D Jacobian? So if we see 3D Jacobian, then we have, like, consider one example. In our example, now the limit, now there is a triple integration. In this example, there is a triple integration where in triple integration where x is 0 to 1, I mean x is 1 to 2, x is, there is a reason. In 3D we have, in 2D we calculated the volume. In 2D, if I have integration over region and fxy dxy plane is calculating the volume of fxy that makes intersection or that make a 3D region along the xy plane. What about fxy dx dy dz? fxyz function over xyz dx dy dz. Can someone give an example? That I have giving example in 2D is simple. I have x-axis and there is a curve line and fx dx is area under the curve. If I have xy plane and there is a surface, then fxy dx dy is the volume underneath. What about I have a function fxyz dxyz, dx, dy, dz. Integration along a volume. Integration not along the surface. Integration is along the volume. Okay. If integration is along the volume, okay, if integration is along the volume, if I have fx, yz function over x comma y comma z, then integration along the volume. What is integration along the volume? That is under question mark. Can you consider this as a volume? It is a hollow. Consider it is a filled one. If it is a filled one, then can you consider this is made of rubber? Not guarantee that rubber density at each point is same. It is filled. It is not hollow. It is filled. Consider it is completely filled and it is heavy. But the material rubber at some point the density is high, some point density is low, some point density is very high, something like that. So it is not evenly packed sphere. That is the case. Then at any point x comma y comma z, x comma y comma z, at any point x comma y comma z, what is the density? That is function over x comma y comma z, f x comma y comma z. This is always nice. This is always nice to kind of understand the pictorial view, how I can view it. Last example we gave where x square minus y square was minus 1, x square minus y square was 1, x plus y equal to 1, x plus y equal to 3. 4 lines. If I draw pictorial in UV plane, then v equal to 1, v equal to 3, and then u into v equal to minus 1. U into v equal to minus 1 if you draw, or u equal to 1 by minus v, it will take this kind of shape. Another one will take this kind of shape. So if this is u axis, this is v axis, one is v equal to 1, one is v equal to 3, and then one is u into v equal to 1, and one will be u into v equal to minus 1. So this will be the region in between. So draw it. If I say I have a region that is x equal to 1, x goes from 1 to 2, x goes from 1 to 2, there is x into y that goes from 0 to 1, and there is z that goes from 1 to z goes from 0 to 1. So if I have a volume, I cannot show you now xy plane because xy plane is not independent. Now xyz volume is independent component. Can someone believe it? XYZ volume is independent. Earlier, XY plane was independent. In XY, X is independent, Y is dependent. In 3D, XY is independent and Z is dependent. Now in 4D, XYZ volume is independent and density is dependent. Density is dependent at each point in the XYZ volume. Then I have a volume region, not on a surface region. Volume region is x is 1 to 2, x into y. X into y is 0 to 1, and z equal to 1 to 2. I cannot show. So if I show it like this, then on x is 1 to 2, x into y is 0 to 1, and z equal to 0 to 1. Okay, whatever the volume region you are seeing, that is the independent component. What is fxy? X square y plus 3xyz dx dy dz. We are landing up in 3D Jacobian. What is 3D Jacobian? Let's transform into UVW plane. Then this volume region, what we are talking about, this region I have to convert into UVW plane. Whatever the integrand is, the density function, this expression is not available anywhere else. Support us. Plus 919483160610 is the telephone number. Plus 91 is country code of India. and 9483160 is the telephone number. Please support us. So, now the integrand or the function over xyz is x square plus x square into y, x square into y plus 3xy z dx dy dz or dxyz volume. Dxyz volume is nothing but dxyz divided by duvw into duvw. So duvw will get converted into du, dv, dw. What about this? Change in the UVW volume, 1 unit volume will bring how much change in XYZ volume? Dx comma y comma z in braces, d braces u comma v comma w. This is the 3D Jacobian. So we have to find 3D Jacobian and then we will proceed on it. Support us and enjoy. Try doing it and then we will meet again.